Welcome back. We are going to start our second unit of the year and we're going to look at graphs. So today's focus is going to be bar graphs and double bar graphs. So let's get started. Let's plot this data on a bar graph. So plot means just to put it on the graph. So every graph is going to need a title. So the title is babysitting earnings. You need to label the bottom as well so we know what is at the bottom. So we have student names. So we have three student names here. We have Nika, and I'm going to just write it this way here. Nika. We have Sally. And we have Ava. So on the left side here, we have to choose a scale because this is where the money is going to go, or the numbers. So this is going to be the money, so earnings. Okay, so we have to choose a good scale. So we see that the numbers are 12, 8, and 6. So a good scale would be skip counting by twos. So there's our scale done, skip counting by twos. We go up to 12, that's the highest number. You can add the next one too. It's up to you. So let's graph these. Nika has $12. So my program does not have a ruler, so please be patient. Sally has $8 and Ava has $6. Okay, let's go on to the next slide. Create a new bar graph for the data below. This time use a scale of 4. So to use a scale of 4, it just basically means you have to skip count by 4. This little corner is 0. This would be 4, 8, 12, 16. I'm going to keep going, 24. And let's go to 28. So now we can put the data on the graph. So we can see with this graph now who has the most money. Do you see any differences other than the scale? That is a difference. And the one thing I forgot to put earlier is a title. You need to put a title. When you are graphing, these things here, they're called labels. You must have them. And I just realized I spelled name wrong. There we go. What do these scales have in common? How do they differ? Well, they all start at 0. So things in common, that means things that are the same. They start at 0. And the difference is the scale, what they skip count by. That's called an interval. So let me give you a closer example. This interval of 2 or skip count by 2. This one here, interval of 5, skip count by 5. And this one over here, we're going to cross some arrows here. Interval of 50 or skip count by 50. Same thing, both are acceptable. What do these scales have in common? So here we see that there's a difference here. We see that there's a little zigzag. And as you can see here, these scales all start at 0. Start at 0. So that's what they have in common. But the little zigzag means there's too many numbers. So we can't plot them all, or the graph will look really long. So we will do more examples in class to show it. But for example, if we were graphing something that had, say, 350, it would be easier to graph it like this, rather than creating your own graph that looks like this. And if you were skip counting by twos and 350 was up here, it would look like this or something like this. So let's describe these scales. Where does it start? What is the interval size? Where does it stop? So the first one is done for us right here. So it actually tells us to start at 30 because the interval, there's a zigzag. So for this one here, it looks like you would start at 18 go up by 3 or skip count by 3, stop at 27. And this last one over here would be start at 350, go up by 10, stop at 390. Now, just to give you a little note, this here where you stop is it's not necessary. I have never asked a student to do this. Let's describe some scales here. So this one here, the scale would be skip count by 4, skip count by 10, skip count by 2. So the numbers aren't always even, they could be odd as well. So what is your favorite season? So this is a tally chart. So when you do a tally chart, what's important to do is to write down how much each box has, or each outcome has, or whatever the option is. So spring has 5, summer has 11, fall has 4, winter has 3. So the question now becomes, what would be a good scale to represent this data? Well, since you did a small sample size, so this is a classroom, so a good scale would be 2 in this case. 2 would be a good case, because then at least the bars can look decent sized. What is the greatest number of tallies? Well, here it's summer. We know that, so that was 11. And usually you have to look at the largest number and the smallest number. That usually gives you an idea of what you want to do. Some people may say you can do a scale of 4. Actually, scale of 3 or 4, those are acceptable. So here we have some examples here. Choose the size, the intervals. So what could you skip count by? Well, here's the first one. The numbers are 2, 9, 6, 1, and 0. A good scale would be skip counting by 2s. Here is another one. Oh yeah, and 0 would be here. This other one here has a larger number set. So here you need to have a little squiggly, and then you can skip count. This one looks like a 5 to me. You don't want to go too much higher than the highest number. And this last one here can be tricky, because there's 2 correct answers for this, and one you can do. The more acceptable answer would be to draw a squiggly and then to skip count it by 5s again. That's what I would do. So you would go, or maybe skip count by 10s, 60, 70, 80, 90, 100. Now, if you were to do this, and I'm going to just do a rough sketch down here, you can also have done this with skip counting by 20s. That is a good option as well. The harder part when you do this is that what goes in the middle, it gets very tricky, especially with small squares like this. So this is the preferred way. This one's still okay, not so bad. Find the range of the data. So range is biggest number subtracted by smallest number. So here we have 92 is the biggest number, 88 is the smallest, and we have a answer of 4. Now, would this be a good interval for? No. The interval for this data, if you did the squiggly, I would do a 2. 4 is okay, but 2 would be more accurate. For this one here, for B, the largest number is 90. Subtract that by 76, which is the smallest number. You have a difference of 14. So the interval here can be a little bit bigger, and I would make that a 4. And for this one here, you have a wider range. 605 is the bigger number, 126 is smaller, and the range is 479. So for me, the interval that would make sense, because the numbers are so big, would be 100. Let's pretend that 4 students prefer spring, 15 prefer summer, 3 prefer fall, 12 prefer winter. What's wrong with my scale? Well, as you can see here, the scale, this is just the numbers of the votes. You cannot do this. And I see this done a lot, where the students just put the numbers that are in their data. This is not accurate. So now let's look at some real graphs here. We got a little introduction. 2 sporting good companies graph their sales in the first half of the year. Which appears to have the highest sales? Well, just by looking at the graph, you would think company A has the higher sales. But I want you to look at the actual intervals on the side, what they're skip counting by. So both have the same dates, same months, but company B is actually better. Maybe they're B for better. Here are the sales in a double bar graph. A double bar graph is when you're comparing 2 things. So in our school, it would be comparing maybe 2 classrooms, maybe their marks on a test, or how much fundraising they've done. So you're comparing 2 stores, and as you can clearly see, there is a key here. See, you have to put this when you are comparing. So company A gets the gray color, company B gets no color. There's a title here, and there's labels here. So obviously company B is better. This proves it right here. What were the total sales in April for company A? So company A, which is right over here, it looks like it's about $50. And for company B, which is right here, it goes all the way here. Now I would recommend using a ruler so you can kind of line it up, and you would see it's about $250. In April, how much more did company B have in sales than company A? So it's basically asking you, what is the range? Big number, subtract by the small number, equals 200. How does the bar graph show this? Well, the graph is longer. That part right there is longer. So that shows you that there is more. And our final slide is going to look at pictograph. I know this is something we did ages ago, but it states here which statement about the pictograph is false. So one of these is wrong. An equal number of students chose volleyball and baseball. Volleyball and baseball, they're both the same. So it says each circle represents 10. So they both have 20. So this is correct. Twice as many students chose baseball as basketball. Basketball is 10. So twice as many would be 2 times. 10 times 2 equals 20. This is correct. Twice as many students chose hockey as baseball. Hockey is 35. Baseball is 20. So 20 times 2 equals 40. Well, this is wrong. And then the last one is the total number of students who chose baseball, and hockey is 55. Sorry, 55. So 35 plus 20. So this is right. So this is the wrong answer. So C would be the incorrect answer. That's all for this video. We'll do some more in the upcoming videos. See you then. Bye-bye.